Welcome to our video on sampling distributions in Module 3. When we think about sampling distributions, what we're really talking about is what would happen if we were to take different samples of the same size from the same population. For example, we have two people, Pete and June, who are both trying to answer the same research question. What is the average price for a gallon of milk this week in the state of Vermont? To try to answer this question, Pete takes a sample of 25 stores selling milk in the state of Vermont and finds that the average price per gallon is $4.29. June is following the same process. She is also going to take a sample of 25 stores selling milk in the state of Vermont. The question is, do we expect that the average price for a gallon of milk will be the same in the 25 stores that June chose as they were in the 25 stores that Pete chose? And of course, the answer is probably not exactly the same. And in fact, the average price in June's sample was $3.99 per gallon. Notice that the average price per gallon in Pete's sample is a sample statistic because it was calculated from a sample, and that June's sample resulted in an average price, which is a sample statistic also, and that the sample statistics varied from sample to sample, even though the samples were taken from the same population and had the same sample size. A sampling distribution is the distribution of sample statistics that are calculated from different samples of the same size taken from the same population. The graph shown here is the sampling distribution that resulted from taking 200 different samples, each one of 25 stores in the state of Vermont, and for each sample, the average price of a gallon of milk was calculated. Each dot on the plot represents the average price per gallon of milk from one of those 200 samples, and we can see how the average price varies from sample to sample. And this is what the sampling distribution shows us. It shows us how sample statistics would vary from sample to sample due to random chance, that is, which stores happen to be included in the sample. Understanding this variation is the foundation of the statistical inferences that we will do in the rest of the course. But in this module, we're just going to focus on some of the characteristics of sampling distributions. First, we'll talk about the shape of sampling distributions. As long as samples are randomly selected from the population and the sample size isn't very small, sampling distributions are usually bell-shaped and symmetric, and this is true whether we're looking at the sampling distribution of a sample mean or for a sample proportion. Next, we'll talk about the center of sampling distributions. Again, if samples are randomly selected from the population, the sampling distribution will be centered at the true value of the population parameter. That is, the mean of the sampling distribution is at the true value of the population parameter that we are estimating. Next, we'll talk about the spread of sampling distributions. And to do so, I need to introduce a new term. Standard error is a special name that's given to the standard deviation of a sampling distribution. The standard error measures the typical amount that a sample statistic deviates from the true value of the parameter. We use the notation SE to denote standard error in this course. When we talk about the spread of a sampling distribution, it's important to realize that the sample size is very important. What we're looking at here is a plot showing sampling distributions for different sample sizes. Each sample is a sample of coin flips, and the sample statistic calculated was the proportion heads in the sample. At the bottom of the plot, we see samples of size 10, and each dot in this bottom part is the proportion of the flips out of 10 that landed with heads facing up. We can see that the sampling distribution when n is equal to 10 is approximately bell-shaped, and it's centered at 0.5, which is the true proportion of the time that we'd expect heads to land facing up. We can also see that there's quite a lot of spread in this distribution. The standard error is 0.14. When we increase the sample size to 50 coin flips per sample and calculate the proportion of heads out of 50, we can see that once again we get a relatively symmetric bell-shaped distribution that's centered at 0.5. But now there's much less spread in the distribution of statistics. The standard error has been reduced to 0.07. As we increase our sample size again from 50 to 100, you can see again we get a familiar bell-shaped distribution centered at 0.5, but now with even less spread, standard error of 0.05. So the important thing to understand is that as the sample size increases, the amount of variability in the sampling distribution decreases. So standard error is smaller for larger sample sizes. What this means is that with a larger sample size, we're more likely to get a sample statistic that's close to the true value of the parameter, and we're less likely to, just by chance, get a sample statistic that's really far away from the truth. One thing I want to just remind you is that we have been assuming, when we've been talking about the characteristics of sampling distributions, that we've been taking random samples from the population. The sampling distribution is centered at the true value of the population parameter if we're taking random samples, because that's an unbiased method of sampling. If a biased sampling method were used, instead the sampling distribution would not be centered at the true value of the parameter. And in this case, if we use the information from a sample that was collected using a biased method of sampling, then we may reach false conclusions. The next steps are to complete the Module 3 activity, then submit it, and solutions will be available so you can check your solutions. After looking through the solutions, or as you're working on the activity, remember that you can ask questions on the help discussion board at any time. And once you feel confident in the material, go ahead and complete the Module 3 quiz. Thanks, have a good day.